closed. Good morning to my talk about air statistics with MongoDB. So it's the first MongoSoup branded talk, so we are very happy to be a sponsor of this conference today. My name is Markus. I worked a lot during my PhD and studies with R. I was working at the Robert Gentleman Lab in Seattle and was an R core programmer at this time. Today I'm working for comSysto here in Munich and working together with Telefonica on some really interesting big data projects, so doing a lot of Hadoop stuff and storing data in MongoDB. The talk today, I will give you a short introduction to R, so probably not everyone is familiar what's R really. So R is a statistical software. It gets more and more famous, it's open source, it's free, but on the other side, some memory issues, the help system, many people think it's not that well established, and it's really difficult to get an open source lang programming or statistical software into production in big companies. So there are several aspects where it's very difficult to work with R. I'm also talk about MongoSoup, and then the main part of the talk will be connecting R with databases, working with really big data in databases and getting this data to R. And at the end, I hope we have some time for questions. Okay, in my view, I took the definition of big data from Wikipedia. I all the time see two aspects. On the one side, it's storing data. We are collecting data from everywhere, from different sources, so we have to store the data. But in the view of analysts, so I'm an analyst, we have to analyze, we have to process the data. It's not only moving data into database and storing everything, we have to start working with these data. So we are on the MongoDB conference, so NoSQL is one of the hype topics in the big data area, and there are definitely several good aspects to work with a NoSQL database, but the relational world we will never lose, so I will have some examples about relational databases in my talk too. Yeah, if you talk about MongoDB, MongoDB comes from the United States. Now, since 1 week, we have a new service here in Germany. It's MongoDB as a service, short MongoSoup. We are proud to be a sponsor of the conference. So what we offer to you is Mongo completely running in the cloud out of the box. So you can go to Cloud Control, create your account, and then you got direct access to a MongoDB in different options. So we have sharding available, we have replica sets, you can have a sharded hosting, you can get your own dedicated hosting, we have programs to move your data center or your Mongo locally into our MongoSoup system. If required, we can provide you with 24/7 German support and many more features. So if you're interested, please join us on our booth to get more information. One important aspect currently is that based on the cloud control infrastructure, MongoSoup is running on Amazon, which means we're running in the EU region in Ireland. And if you have special requirements that your data have to stay in Germany, get in contact with us. The beta program for a German hosting is starting next week. So we have a German cloud provider, and we start moving first MongoDB instances to German Munich-based hardware. Okay, MongoSoup in 5 minutes, just give you an idea how it works. So the slides will be available for download after the session. So you can download it. It's very simple. You have to go to Cloud Control. You have the website. You create an account. You have to add your billing address. But the first 30 days of testing are free. Even for the MongoSoup service, for a small one, it's free. you have to create a so-called new app. An app means some kind of application, some code. An app could be, or even can be MongoSoup. So create a new app and call it our MongoDB. And now you have to connect your app with MongoSoup. Therefore, you have to install the command line tools from Cloud Control. So you will find a lot of documentation on the Cloud Control web page. And then you need one command to add MongoSoup to your app. So it's written here. It's the name of your app /default add-on add MongoSoup, and then the different kinds of MongoSoup hostings available. So if you check the MongoSoup site, you will see we have small, medium, large, X-large, and different ones. And yeah, and then you can go back to the web console of Cloud Control and see if everything is up and running. And I will try a short demo here. So that's the web interface of Cloud Control. I'm already on the tab Add-ons. And you will see here we have this our MongoDB app, and there's only one add-on in here, or two add-ons. One is the alias for another domain, and MongoSoup. And if you press on MongoSoup, here you can get your credentials, how you can connect to your MongoDB. And we also have a dashboard for MongoSoup. And here you can see there, it's a MongoSoup control panel. You can see that there's one database, you can press on it. Here you can see 3 collections, 115 megabytes. Then you go in, you see the different collections, the size, and you can even go more in there for viewing the content and changing the content and so on. So it's really simple, works very well. Yeah, let's go on for now. We get back to MongoSoup later. In the beginning I talked about big data, it's storing and processing. I don't want to talk too much about processing today. I think there's one important aspect. So far we did a lot of analysis which were backward looking, doing summary statistics on our data. Now many people start talking about quasi real-time analysis. As we had in the first talk today, where people try to create real-time systems. But what's more and more getting interested is that we are trying to use our data to do forward-looking prediction on our analysis. So we have more and more complex methods, we have more and more data, which needs much more processing time. So it's next to the methods, we need enough processing power. So if you're interested in here, how you can do this with R, check our Strata tutorial in London, which is in less than 3 weeks. Yeah, now let's get to R. Who in this room already used R? Okay, half of the room. So R is free, it's an open source. It was designed in 1995. The idea was to have a tool for statistical computing, so not only for statistics, it was for statistics and computing, and additionally to have a tool for visualizing the data. So today you can use R to manage your data, so doing these classical ETL processes with R. You can analyze it and afterwards create presentations or reports from your analysis. So for example, these presentations are completely written in R. All statistical methods are more or less implemented in R. It works on all machines and all operating systems. And very similar to MongoSoup, you have a very huge community. You can get a lot of support from the community. Just go to the R web page. Here you find a lot of links and forums and mailing lists. Another point on R is R core. It's about 85 packages which provide the core functionalities like importing data, creating summaries, creating simple plots and all that stuff. But today we have more than 5,000 R packages which are provided by the community. and which give you much more features for R. So, for example, the connection to MongoDB is one of these packages for creating nice plots, accessing Google Maps data, and so on for biology. So go to the CRAN webpage, that's one of the most famous mirrors for R packages, and you can find more information there. And yeah, these packages provide us the possibility to write our own code and to contribute it to others with new packages. Really famous R got in the year 2009 with an article in the New York Times, and it was featuring Robert Gentleman and Ross Ehackers. Both are more or less the fathers of R, and it was at the same time as the Bank of America jumped on R and exchanged their complete background processes running now with R. So it was the first really big company who put the efforts in R. Okay, R, it's a command line tool. You install it, you start a small command line editor, and many people say, ooh, R, I have to do so much coding and it's very difficult to do any analysis in there. You should check RStudio. It's a project running about 1.5 years now, which provides you with a very nice IDE, so development environment, which is similar to other development environments. So here you have your code, here you have your console where it executes your R code. Here you will see, for example, plots, so you can show your packages or files. Here you see your workspace where you have stored your data. Version control is included. If you enable it, it jumps up here. So there are a lot of nice features in here. If you go on with R, you should definitely check for RStudio. Okay, to get everyone some impression about R, I will not talk too much about this. Some R code in here, so you can simply write your equation you're interested, press enter, and you will get your result. You can store variables. Mostly you should use this pointer operator. Yeah, you can do calculations with these variables. You also can define vectors. So vectors are very important in R. These are the basic data structures. There are different ways to create vectors with the C function or just with the double point, which creates a vector from 1 to 10. It's stored in the variable x. Then we just type x, press enter, and we get the input out here. And we also can run operations on these vectors, check which is smaller than 5, and you will get a Boolean vector. So all these functionality which we are more or less used from functional programming languages. Yeah, here's some more examples. You can do subsections of vectors. This is a way to run a function on any data. So this calculates the mean value of the vector x. We have a very powerful help system in R. If you don't know a name, but you know you want to calculate the mean value or any clustering, just type help, and then the name or the text you're interested in, and you will get some proposals for help files. If you know already the name of the function, you can use question mark and function name to get the documentation for the function. Here another example which loads one of these 5,000 external packages. So it's a package which holds the data for three-dimensional data. It's called Onion. This function data loads the data for the bunny. Head from bunny shows us the first 3 lines of the data, and you can see it x, epsilon, z, so it's a 3-dimensional data set. And there's a p3d function which can render and plot it, and now on the presentation I cannot turn it, but in R you can turn it around and change it. And for example, there's currently a company which provides you with a 3-dimensional plot from your R figure, so it's really nice. So that's one of the stuff you can do, but it was designed for statistics, so there are also a lot of statistical tools in there. Here, for example, I've chosen a data set and running k-means clustering on it. I defined k for 4. The first output I get, it's a statistical output. Yeah? It's probably not that useful, but for statisticians they can work with it. So you get the centroids of the cluster means, you get the size of the clusters, and here a clustering vector. It gets more interesting, for example, if you plot these results. So every point is the point of the data set. These other points are the centroids. Another one is here. And if you look at the code, it's more or less 2 lines of code. And especially these kegs, point size, kegs, color, these are more or less just for designing the plot, making it much nicer. So it's really less code of creating these kind of figures. Okay, one last aspect about our introduction. If you work with big data, you have a huge amount of data, and it's often very difficult if you're an analyst to work together with your business intelligence or management staff. They are interested in many different figures, and then you start creating huge PDF reports showing each scenario, and it gets really different to handle all this. There's a new package called Shiny or RShiny. It also was developed by this RStudio team. It's an interactive web application which can be created fully out of R. So you only need R code. In R you can define something like sliders, drop downs or text fields, and then push this to a very simple web server and just post the URL to your management or team, and then they can use this interactive analysis platform to do some defined analysis, and they can choose what they are interested in. So I will show you an example together with MongoDB later, so it could be really helpful for presenting results out of R to any of your colleagues. And it's no HTML, no JavaScript, it's everything in R. Okay, R and databases. Big question was on which point I will start talking about MongoDB and NoSQL. I decided to start with SQL, especially if you think about processing. SQL gets back in many aspects. So if you look into the Hadoop ecosystem, you have Hive where you run SQL queries, you have these new real-time Hadoop, Impala or Drill. Most of them even take SQL as a querying language. So we somehow again have to go back a little bit to the relational SQL world, and even in R it's often very interesting to connect to some Excel tables to get data out of there. A good way here is to choose the ODBC connection, and then if you check R for a table you need some kind of rectangular matrix. In the beginning I told you we have vectors as the most central storage part in R, and from vectors you can build so-called lists. So a list is a vector with a name, so you can give the name to the vector, and then if you combine several lists together then you get data frames, which are matrices with column and row names more or less. And that's a perfect data structure to store your R data, to store relational data in R. Again, giving you an example, I've chosen a data set. It's called Iris. It's one of the mostly used data sets in R. In every training you will hear about Iris. It's small, but small data set from the biology area, where we have different numbers and some categorical variables in there. And I just loaded this data set, presenting here the head of the data set to get an impression about it. And here with the command class, I check which class is this object, and it's a data frame. It's rectangular, so you have column names, so it's perfect for relational word. And now if you're an expert in SQL, you probably don't want to learn some R syntax, you can load a package called SQLDF, and then with the function SQLDF you can fire up all your SQL statements. And here an example, similar to this head function where I plotted the first 3 rows, I can do the same with SQL, select star from the dataset iris and limit it to 2 lines, and if you think about the first one was 5.1, it was the exact same. And the other one is here in the count example, count how many data sets are in this data frame, so these are 150, so it's very nice to use or evaluate your SQL syntax in there. And so in the background, some information, this SQLDF package has some flat table system in the background, so it turns these data frames into SQL and flat tables and then runs with an own SQL engine the SQL queries on it. So it works well for small examples. You shouldn't try it with big data. Yeah, to close the relational world, R with more than 5,000 packages, you can more or less connect to every database available today. You have connectors for MySQL, Postgres, Oracle, JDBC, RODBC is available too. SQLite is used more and more because they implemented an SQLite engine in there. But we have one big problem in here. If we run something like this, we fire a batch job onto our database, and the database returns the full result, and we have to read the full result into the database. If you talk about big data, you probably have a document where you have 1 million of rows and 1,000 variables, so it will get a huge matrix and it probably will kill the memory of your machine, or R will get problems handling this amount of data. So all of them are implemented in the same way, that they read the full result in R memory from the query you send to your database. So you have to really think about your queries, be careful that the result didn't get that big. Okay, let's get to MongoDB. Already talked about cron, this big repository with R packages. On cron you can find 2 packages which you can use to connect to MongoDB. One is called rMongoDB and the other one is rMongo. I start with rMongoDB. It's so in the package is still written. It's supported by Tangent, so it's supported by MongoDB. But if you go onto the cron today, you will see it's not longer available. You can just get it from the archives. So the maintainer gets lost. No one knows why he's not responding to emails. MongoSoup is currently talking to the people from MongoDB, and we will take over the probably will take over the rMongoDB and go on with maintaining it, and so that we hope that it will be available in the next 2 or 3 weeks on cron again. As you will see in my examples, it's very powerful for big data, but it's difficult to use in view of a statistician. rMongo, it's very easy to use. If you're used to using the Mongo shell, you can use rMongo. It's more or less exactly the same syntax, but it has limited functionality, so you cannot do all the same functions as on the Mongo shell. For example, there are some issues with the aggregation framework, or you cannot create indices from R out. And again, it's the same problem. It reads the full batch results into your R, so it probably will kill your R machine. And I never managed to install it on my MacBook, so there are some issues with Mac, but it's discussed in many forums, so it's an issue on the package. Yeah, I have one slide with code about rMongo. Some people just want to use rMongo because it's so simple. You have to load the package, then you have to create a connection. Here I use my credentials for my MongoSoup, so that's my username, that's a database, that's the host of the MongoSoup database, that's a port. which create a Mongo object, which is an object which stores the connection. And then you add to these objects your authentication, so add your username as your password, and then you can use it to run queries or anything against your MongoDB sitting on MongoSoup. Yeah, for example, this command, you can use it to show the collection in here, you can run queries, so here you can put in your JSON syntax, connect, so this means connect to the MongoDB on MongoSoup, choose the collection zips, and run state equal AL. So everyone doing the Mongo University probably knows the zips dataset. So it's a classical dataset in MongoDB, for example. Here the command for inserting data, and that's a command to close the connection to Mongo. But I personally would like to push you using our MongoDB. So it was developed in cooperation with MongoDB, and it's based on the C driver of MongoDB. So all of you know, familiar with implementing C code in connection with R will find several points where it gets very similar. So you have to load the library R MongoDB, again, create a connection to the MongoDB. So now it's a little bit another command, it's called mongo.create. First of all, you have to define the host, then the database, then the username, and then the password. And here, then I store this in the Mongo object. I printed the Mongo object, and you see it's a C point. It's a C object with pointers in there, and that's the way R visualizes pointers in C, and you can start here, for example, read some information out of it. So, but more or less you cannot use it very much. Yeah, and here I have a command, mongo.get database got collections. So with this Mongo connection we just created the collection name, and you will see it reads from my MongoSoup database the collection zips, CCP, and test. So it's the same as we had in the dashboard before. Zips is the collection from the Mongo trainings, test, it's some test import, and CCP is, Cloudera had this data science challenge, so it's a data science challenge in there. So it's a nice big data set about MoveIts, which is really big data, or more or less big data. And yeah, here the same, you should try disconnecting from MongoDB. If not, you will start having a lot of open connections from your R session, which will limit the performance of your queries. Okay, now let's get to the difficult part. You cannot use from R simple JSON. You have to write BSON objects in R. In the first talk you heard about BSON. BSON is another representation from JSON, which is used internally by Mongo. So the idea in R is, first of all, create a BSON buffer. So the first line creates an empty BSON buffer, and with the second line we append the state equal AL. It gives us a true, so that means the appending worked well. And from this BSON buffer, we now create a BSON object as stored in query. If I print query, you can see this BSON object. So you cannot work directly in R with that, but it's a BSON object created in C, and there are some methods available to visualize them in R. So that's the name of your variable value, and two main that it's a character, and this AR is not a number or double, it's a character. And now I use the function mongo.find.one, so it's from the syntax a little bit different to the Mongo shell, but it's similar. Mongo connection, the zips, Mongo connection, zips collection, run the query. The result, it's again a BSON object, so you can, if you're familiar with the zips dataset, you can see, okay, you get the city, a location, the number of population, the state, and an ID. And but it's again a BSON object, you cannot do anything in R with that. There's a function called MongoBSON to list, which moves this BSON object to a list object in R. I stored it out, and as I told you, list objects are vectors with names. So then I took the, if you go back here, for here you have city, location, pop, state, and the same here, out $loc gives you the location, out $pop gives you the population, out $state gives you the state. Here, for example, I checked the type of this loc, and it's a double, so it's really numbers which I now can start working with. So in this case, we only have took one out of it. It's not big data. We probably would take more out of it. And now here we have the big difference to all these other database packages. If you run Mongo find, same collection, same query, we will get a cursor object. So there are no data stored in, it's only a cursor pointing to Mongo and your query result. And now you have to create a while loop which loops over your cursor. So Mongo cursor next from this cursor object, and here Mongo cursor value gets the actual value. I store this in the variable value. These value objects I return to R value. Now it's a list which I can read in R. And now there are different ways to combine these data sets. I just used this as an example. I used the command rbind, which row by row binds together the objects, and loop over the complete object with my while loop. At the end, I destroy my cursor, and if I check my result value, you will see I got a data frame with all the results I queried in there. And again, you have to be a little bit careful. We're talking about NoSQL, it's not a relational word. Here in this location, we have this vector of two doubles with location in there. Therefore, we cannot show it directly in this view. But this BSON to list object creates a list in a list object. So if you go in there, you in the end will see that there are two objects in there. So you can do analysis on it, but on this plot, on this table plot, you cannot see it. Okay, so if you see it, if you're a statistician, it's a little bit difficult creating these BSON objects. So it's all about creating BSON objects. There's some support to creating BSON objects directly from lists and the other way around. So I would like to point you to a lot of help in there. So these are the most important commands in R to create these BSON objects. And here I just put some example code for the aggregation framework in there. You can do it, it works very well, but it's a lot of code. And you will find, for example, some examples in Stack Overflow, and together with a colleague we are working on some kind of cheat sheet, so where we put all the most important commands together. So yeah. Okay, a little bit more examples so that you can see you can really do analysis on it. It's from this Cloudera Data Science Challenge. It's a data set with 20 million of entries of movie actions, and yeah, I created a query. And here I have to hurry up a little bit, the time. I created a field object, so I just want that this query returns me the field's user and type. So here in Mongo find, I took the CCP collection, the query, and the fields. I put the limit that I only want to have for the demonstration here 1,000 objects. Again, my while loop, and I created a box plot from this, and you can see that in the data set, an average about for every user there are an average about seven movie actions, so 7 times in 1 week they started a movie, stopped a movie, or recorded a movie. There's one heavy user, but there are also some users which don't use it very much. Okay, due to the time, I will skip this demo. You can check our GitHub. I developed this very small tool called Shiny Mongo. It's a MongoDB user interface which is similar to the MongoDB Soup dashboard to view the content in MongoDB. It's completely written in R. It's less of 200 lines of code. Just having an example for using our MongoDB and Shiny together. Okay, summary. R is open source. It's a very powerful tool for statistics and big data. You can access more or less every database available on this market. It works with MongoDB very well. You should use our MongoDB. And I would like to invite you, just start playing around. It makes really fun. I put some links on it here. And yeah, at the end, I would like to invite you to join MongoSoup on the booth, so to get some t-shirts, or we also have a small game here, so you can win 1 year free MongoSoup. And if you're interested more in these topics, we have our trainings by comSysto here, we are on the Strata, and we're hosting a lot of meetups. For example, this week on Thursday, we have Ted Dunning, the very famous machine learning Hadoop guru here in Munich, giving a talk. So join us to learn more about big data or to contribute